Hey builders, and welcome to the definitive guide for base accounts. For too long, the on-chain user experience has been plagued by friction, confusing seed phrases, mandatory gas vicinity tokens, and endless transaction pop-ups. These are the silent killers for on-chain user adoption. Today, we are going to solve that. Base accounts are the foundation for the next wave of on-chain applications. They are not just another wallet. They are a programmable multi-chain account layer built on the ERC-4337 standard. This tutorial will take you from zero to hero, showing you how to leverage this powerful technology from Coinbase Java platform and Base. We'll cover everything from the core concepts to a hands-on coding tutorial where we'll build a full-featured on-chain application. Let's get building. Before we write any code, it's crucial to understand the fundamental shift that base accounts represent. We are moving away from a rigid user-managed model of traditional wallets, EOAs, or externally owned accounts to a much more flexible, developer-friendly, and programmable model. The best way to see this difference is a direct comparison. This is just an upgrade. It's a completely new way of thinking about user accounts on chain. So we have a visual table over here which would explain the different features and how they work in externally owned accounts and base accounts. So first of all, we have the control mechanism by which a user controls their wallet. So in externally owned accounts, this is controlled by a single static private key, which is the seed phrase. And if you lose the key, you will lose everything. You will lose complete access to the wallet. So here, the only backup is the seed phrase. And if you lose the seed phrase, you lose complete access to the externally owned account. Now let's see how this works in base accounts. So in base accounts, is controlled by programmable smart contract logic. So you can enable multiple recovery options like passkeys, social recovery, and multisig as well. Now let's see how gas fee payment works. So in externally owned accounts, you must hold native tokens to pay for gas, which is a major friction point. But when it comes to base accounts, these are highly flexible. Gas can be sponsored by your app, which is gasless transactions, or paid in other tokens like USDC. Now let's see how transaction flow works. For externally owned accounts, each on-chain action requires a separate signed transaction. The best example for this is how swap transaction works. So first, you would have to approve the amount, and then you would have to transfer it to the contract which is handling the swap transaction logic. But when it comes to base accounts, it natively supports atomic batching. So you can bundle multiple operations into a single transaction requiring only one signature. So you can do the approve and transfer transaction in a single signature using base accounts and smart wallets. Next, we have account recovery. So in externally owned accounts, this is irreversible loss. No built-in recovery mechanism if a key is compromised, which I already mentioned before in the first point where seed phrase controls everything in EOAs. But when it comes to base accounts or smart wallets, programmable recovery is possible. Think you can do we have social recovery options as well through trusted guardians. Next, we have advanced features. Now, in EOS, this is limited to basic transfers and contract calls. But when it comes to smart wallets natively enables app-specific features like sub-accounts, session keys, or on-chain spend permissions like subscriptions and more. This paradigm shift, powered by account abstraction through the ERC-4337 standard, is what makes next-gen UX possible. Work is cheap, let's build. We'll create a Next.js application from scratch that demonstrates the core pillars of base accounts: seamless authentication, frictionless payments, and truly magical UX enhancement. First, let's get a development environment ready. So we'll use the npm create wagmi to quickly bootstrap a project with wagmi pre-configured. So I'm already on my terminal over here. I'll use npm create wagmi at that latest, and I'll keep the name of the project to base accounts demo. So let's click enter. So I'll just proceed with installing the packages. Let's go with React. We'll go with next. And that's it. Let's navigate to the project, cd base accounts demo. And here, along with the other packages, we'll install the base accounts packages. So I already have the command over here. So we'll install the various packages that came with the scaffolding of the project. Along with that, we'll install the base org account package as well as base org account UI, which handles base accounts. So I'll hit enter. So once the dependency installation are done, we are done with the project setup, and now we can open up the project in ID and start with the development. So now that we have our project set up in the ID, let's explore the project structure once. So we have the env local files and the next configurations and package.json configurations. And then we have the src folder where all of the projects files would reside like wagmi.ts and app components. So now let's explore the env.local. So here we will remove all of this and we will add the paymaster configuration in this env file. So in this env local file, make sure you have added your paymaster URL from the Coinbase Devo Platform console. So you can just navigate to Coinbase Devo Platform console and get your paymaster URL from the console itself. So just navigate to the Devo Platform console and there you will find the paymaster configuration and you can find the paymaster URL for both base Sepolia and base mainnet. So base Sepolia and base mainnet have different paymaster URL configurations. So make sure that you are checking those. So while you're working on mainnet, make sure you're using the base mainnet paymaster URL. So this is the only env that we would need for our application, the base Sepolia paymaster URL. Once that is done, we can move to the wagmi.ts file and uh, make the changes needed here to accommodate base accounts as well. So in this wagmi.ts file, we'll remove this code and we'll add our own wagmi configuration over here. So it's a pretty simple configuration. There isn't much working over here. It's just, first of all, we have the imports like the HTTP and create config imports from wagmi and the base Sepolia chain config import from wagmi chains, and then the base account import from wagmi connectors. So as we are only using base accounts, and there's the base accounts tutorial and demo. So we'll be using the base account import from wagmi connectors. Once that is done, we'll create a wagmi config using create config function import from wagmi. And here we'll first set the chains to base Sepolia, and in the connectors, we'll set up the base account connector configuration. So we'll use a base account import, and in that, we'll set the app name to base accounts demo and app logo URL to a logo URL that you want to set. I have just set up a placeholder URL for this. This doesn't work. So make sure that you set up a proper logo for your app logo URL. Once that is done, we set up the transports using the HTTP import from wagmi. So we'll set up the transport for base Sepolia testnet. So make sure that you're doing, and we'll also enable server-side rendering as we would have API files in this Next.js configuration for verifying the sign-in configuration. So we'll be using sign with Ethereum in this demo. So we'll make sure that the server-side rendering is set to true. After that, we'll give an export function to get the config. So if you want to use this config anywhere in the project, we'll just use this export function get config and use this wagmi config everywhere in the project. Now, once we are done with the wagmi configuration file, we can now move on to adding the various features of base accounts like sub accounts, magic spend permissions, etc. So for that, we'll keep a single lib folder where we will keep all of the files in a systematic order where each file would represent the various features provided by base accounts. So here in the assembly folder, let's create another folder, lib, where where all of the base accounts functionality files would reside. And here we'll first create auth.ts, which would show how signing with Ethereum works with base accounts. So I'll go ahead and create auth.ts. So here we will add the configuration for signing with Ethereum for base accounts. So I already have the code. We'll go through this code line by line and see how it works. So we have the code. Before that, there's a small note that I have added as a comment over here. So in this note, what we are trying to say is that this helper provides an SIWE like flow. It generates a one-time nonce and verifies a signed message, but it is not wired by default in our demo, as we want to keep the authentication minimal for this demo, and we want to make sure that we are able to cover all the different functionalities provided by base accounts. So for this demo, we'll be keeping the authentication very minimal, and we won't be doing the exact SIWE flow, but we'll definitely be showing how it works and how you can use this in production. So in production, first of all, you should make sure that nonces persist in a shared store. Either you can use a Redis-based storage or Redis-based cache storage, or you can use a pure database for this, be it MongoDB, SQL, whatever you like, and enforce single use. So make sure that once a nonce is used, it can be used anywhere. If a nonce is used repeatedly, it can lead to security issues in your application. Next, there's a verify flow. So once you have made sure that nonces are secure, you make sure that the verify flow is added to your application where we verify the address, message, and signature. Server side, this is a very important note. Make sure you're verifying any messages server side. If you do it client side, there is a very big security risk, as the verification in client side could lead to exposure issues. So make sure that you do it server side using VM before issuing a session. and consider binding the session to the address and rotating tokens appropriately. So a session should only relate to the address, even the nonces. So this flow is very important. So make sure that you're using all of this in production, as this is a very big factor for security as well. So let's go through this code and see how it works. So first of all, we have the imports from VM and VM chains. So we have create public client and HTTP and base from VM chains. Once that is done, we'll create a public client for VM. So that would be on chain base and transport would be HTTP. And for now, we'll set up the nonce in an in-memory store using the set data structure, and it would have the data type of string. Next, we'll keep a function to generate nonce. Again, here we are generating the nonce using the random UUID import. So, and once that is done, we add the nonces to the in-memory store, and then we return the nonce. Once that is done, we have the verify signature function where we have the various parameters like address, message, and signature. And here we have a try catch block. Inside the try block, we first extract the nonce from message. So we'll extract the nonce, and then we'll make sure that if the nonce is invalid or used, if it's invalid or reused, we'll reject the whole session, and this function will return a failure. Once that is done, we'll verify the signature using client.verify message. So you don't need to do any manual verification over here. VM provides a verify message function, which will automatically verify the message based on three parameters: address, message, and signature. Once that is done, we'll return if it's valid or not. This valid is a boolean, so it will return true or false. And once that is done, we have catch error. So this is the catch block where we make sure that if there is any errors, errors are returned to the console, and the devs can debug it as well. So that's it for signing with Ethereum verification. So make sure that you're using this properly in production, and you keep note of all of these points that we just discussed. And now that we are done with this, now we can go to the app folder and create the APIs for demo verification. So in the app folder, create another folder API. And in this folder, we'll create another folder auth. And in that folder, we'll create another folder verify. And in this verify, we'll have an API.ts file. And here we will keep the demo verification code. So as I mentioned before, this is only for demo, where we'll be just returning the verification. We won't be actually using the verify message function, but make sure you're properly verifying the message in production scenarios. So I already have the code over here. This is again a comment to make sure that this is a demo behavior. Don't ever use this in production. So first of all, we get the imports from Next server to initialize an API. So that would be next request and next response. Then we create an in-memory store for nonces, and then we have the post function which defines the API. So first of all, we get the address from request. Then we make sure that the address is present in the request. And once that is done, we create a session token. This is simplified. In production, use proper JWT, which session secret. So use a proper JSON web token. For demo purposes, we are using simple encoding. In production, again, use proper JWT. So here we'll generate a demo session token, and we'll generate a demo response as well. And we'll set the cookies in the response as well, so that this persists along the session. And once that is done, we have the catch block which returns the errors if there are any errors in this post API response generation. And we have another get API which generates random nonsense for demo verification. So again, this is a demo verification SIWE flow for real production scenarios. Make sure that you are using the flow that we use in auth.ts, and you're using client.verify message or VM's function verify message to properly verify the Ethereum messages. So once we are done with the sign with Ethereum flow, now we'll move on to the next stage, where we will create the base account provider file and its logic. So this file's main motive is to make sure that the wallet connection and its components are working properly. So in the lib folder, we'll create another file, base account providers.ts. And here we'll keep the various logic for making sure that wallet connection is properly set up and wallet connection is consistent across sessions as well. So in this, we'll keep the logic for that. And I already have the code, so I'll just push it over here and let's go through this code line by line and see how it works. So first of all, we'll get the imports from base org/account. So we'll use create base account SDK and provide an interface from base org/account package. And then we create another interface for Wallet Connect response. So this is how the Wallet Connect response looks like. So we have the accounts parameter with an array data structure where we have the address and the various capabilities of the address. So smart accounts have various capabilities like sign with Ethereum, and you can add various other capabilities like batch transactions, which will uh, which will initialize later as well. So yeah, once that is done, we'll catch the provider as well, and we'll keep the provider interface for this. Next, we have the get base account provider. So here we will create and cache a single base account provider for the application. So we'll use the base account provider and base account instance directly from this file. So this provider will implement the EIP-1193 interface, and it supports new base account RPC methods like wallet/account and wallet underscores send calls. So this new RPC methods like wallet underscore connect and wallet underscore send calls enables various smart account features like batch transactions. So here in this function, we have if we have the if cache provider return cache provider instance, and here we'll initialize the SDK using the create base account SDK method with the app name and app logo URL, which we did in um, wagmi.ts as well. After that, we'll return this provider, and that's it for this base account provider function. Only motive, and the only functionality of this function is to return the provider. Once that is done, we ensure the provider is connected in wallet agnostic way, and we'll prefer wallet connect for this method. So in this function, we'll ensure that the base provider is connected throughout the session of the application. So in this try catch block, we'll use the wallet connect method for base account authentication. So this is a very important part of this functions, and not just this function, various other functions that we are going to create for this application. So provider.request is a method to call the various functionalities of base accounts or in general smart accounts. So here we are calling the method wallet connect using the provider.request method, and the params would be version 1. So we keep the version 1 and capabilities. Uh, no capabilities are being used here, and as is this a wallet connect method. And once that is done, we have the catch block where we make sure that if the wallet connect is not supported, it will fall back to ETH request accounts. So this will be the fallback, and we'll just use provider.request ETH request accounts. So this provider.request is a very important function. And here the various methods you call like wallet connect or beat ETH request account is the ones that trigger the functionality using the smart accounts. Next, we have the base account authentication helper. This is the one which will authenticate with base, and so here we'll use the sign with Ethereum method. So first we'll get the provider, get base account provider, which we have already created, and then we'll get a fresh nonce. We'll prefer provider, else we'll generate locally. So we'll generate a fresh nonce. Then we'll connect and authenticate using Wallet Connect with sign with Ethereum capability. So here we'll again use provider.request method with the method Wallet Connect and params with version 1. And this time in capabilities, we'll use the sign with Ethereum method with the nonce and the chain ID. This chain ID is for base. Then we make sure that this matches this type, the Wallet Connect response type. Once that is done, we set up the accounts and the various addresses. So we set up the accounts, response.accounts, and the first param from response.accounts. Then we get the address from the account, and we set up the sign with Ethereum as well. So accounts.capabilities.sign with Ethereum. So before we move to other functionalities, let's first try out the sign with Ethereum using base accounts and create the UI as well so that we can test it out. So in the SRC folder, first we'll create a components folder where we'll create the login form .tsx. So not in the SRC, sorry, my bad, add folder. So here, let's create a components folder. Let's delete this, which was created before. Yeah. So once you have created the folder here, we'll create another file, login form.tsx. And here in the login form.tsx would be our base account connector as well as the sign with Ethereum logic as well. So already have the code. I'll paste it over here and we'll go through it line by line. So first we have the create base account SDK import from base org/accounts, and we have imports. Then we have the login form props where we have the on signing in and is signing in props. Once that is done, we have the export function login form with the props on signing and is signing in. And once that is done, we have the function handle signing function where we have the try catch block where we first initialize the provider using create base account SDK provider nonce and we use the provider.request method, which is wallet underscore connect method to set up the connector. So here we have the various params like version, capabilities, sign with Ethereum as we are using sign with Ethereum. And once that is done, we will define all of the types as well, like accounts, address, sign with Ethereum with message and signature. Once it is done, we extract the sign with Ethereum message and signature and verify on a server, which is the Next.js server. So we have the account, we have the address, and we have the sign with Ethereum capability as well. Once it is done, we extract the message and signature and we verify it using slash API slash auth slash verify with the fetch functionality. Once it is done, if everything is okay, uh, it will move on to the main page. But if not, it will show verification failed, and that's it. Then we have the return component uh, where we make sure that the button has the perfect styling with the div and span components as well. So now we are done with the login form.tsx. Now let's fill up page.tsx and then we can demo sign with Ethereum as well. So already had the page.tsx code. I'm going to paste it over here. So our step one, as mentioned before, sign with base account. So here we have the use state, use account, use connect, and use disconnect imports from wagmi, login form import from login form. And then we have the base account tutorial component where we first initialize all of the hooks like use account hook and the use connect hooks. And we extract account connectors from the hooks. And then we have the disconnect, use disconnect hook as well. Then we have the core states, is signing, which are the signing in state variables. And then we have the universal address. And then we also make sure that the user stays connected throughout the session. So that's why we have the ensure connected function. Then we have a simple sign-in handler, which will basically use the login form.tsx to handle the sign-in. So here we just set up the uh, post state variables, and that's it. This is a simple sign-in handler. And then we have the various styling components, CSS styling components. And once that is done, we define the return function with the header authentication. So here we have authentication using EIP-4361 and the connect wallet button states as well. And once that is done, if the wallet connection was peaceful and authenticated, it will show us this state with the authenticated and the address. So we are done with the UI. Now let's test this out and see how sign with Ethereum works. So now let's run npm render here. So we should npm render. And I wish so we were able to get the initial sign with base UI. So I'll just click on connect wallet over here. So I'll just click on confirm sign into base account demo. And then we have the sign with Ethereum, sign with base button. So the initial and the default sign with base styling is like this. And that's why it's showing the white button over the white UI. So I'll just click on sign with base button. And here it should show sign into base accounts demo. I'll just click confirm. It will ask for my passkey. I'll just do this. And yep, we were successfully able to use the sign with base and now we authenticated with the account. And our step one is complete. Now we can move to the further functionalities. So for that, we'll create another file in lib folder that is gas sponsorship.ts. So sponsor yes. And here we'll keep the various functions related to gas sponsorship using base account. So I already have the code. We would only have a single function here, which would handle all of the gas sponsorship. So for tutorial purposes, we want to make it simple and show you how smart wallets can easily handle gas sponsorship. Instead of creating another relay account or anything like that, smart accounts can internally handle gas sponsorship by themselves. And using CDP and base features, we can do this in a very simple manner. So I have the code. It's less than 100 lines of code that should say everything about how to do gas sponsorships using base accounts. So first of all, we have the gas sponsorship imports like ensure base provider is connected and get base account provider from lib base account SDK. So there's just some naming issue. No need to worry about this. Next, we have the interface that is paymaster config, where we keep the paymaster config interface like the URL, the type. So here we have kept type to each sponsorship and the sponsorship rules like max, gas limit, allowed methods, and daily limit. So here, next we have the paymaster config. So here is a very important note. In production, you use your own paymaster proxy endpoints for security and control. So make sure you're always using paymaster proxy endpoints instead of direct endpoints, so that you have maximum security and control when you're using this paymaster configurations. So, for example, if you're creating a Next.js project, you can go to the app file and here you can create another API for handling this proxy endpoints. For this tutorial, we won't be doing this. We would be directly using the paymaster server URL. So make sure that in production you are using your own paymaster proxy endpoints. So here we'll keep only one paymaster config that is default. So um, again, proxy or CDB paymaster URL set through ENV for security. And next we have the URL where we'll set up the paymaster URL. And I have also set up the paymaster URL in a default as well, like in proper constant way, just in case we don't have any errors for this tutorial. But again, this is not recommended for production. Make sure that you are never exposing this API or this URL in client side Next.js or React project. So make sure that you're not never doing that. Next, we have type, ethos constant, and the sponsorship rules like max, gas limit, and daily limit. So this you can set up the sponsorship rules according to your project or according to your application. So next, we have a single function which would send the sponsored calls or send sponsored transaction. So what this does is that it takes parameters like user address, the calls, so array of low-level calls to execute, and the chain ID. So in this case, chain ID would be base Apolia for this tutorial. And we are keeping this sponsored calls function to support batch transactions as well, as we'll be executing batch transactions in the tutorial application as well. So here we already discussed what are the parameters taken by this function, and it returns a promise. Next, we get the providers using get base account provider that we created in the base accounts provider.ts file. And we also ensure that the base provider is connected. So these are various state management functions that we have kept in this Next.js project. Next, we have the try catch block, which handles this function. So first of all, we map all of the calls that we have got in the send sponsored call function. So we map all of the calls using a variable normalized calls, and we make sure that it's in the proper format. Like we get all of the parameters like to data and value. Next, we have the transaction hash. So here we'll get the transaction hash that we have uh, processed during the transaction. So here we'll use the provider.request method that I discussed before. Provider.request is the one that initiates any kind of transactions using smart accounts. So here we'll use a wallet underscore send to calls method, and with the parameters from chain ID version with the calls that we have already formatted to normalized calls, and with the capabilities. So in this capability, we'll use a paymaster service, and here we'll pass the URL along with the sponsorship rules and the data. So make sure you're using wallet underscore send call methods to enable capabilities like paymaster service and all of the other configurations that smart accounts provide. Once that is done, we return the transaction hash using the function. And if there are any errors, it will return none and give a console error specifying the error. And that's it with a gas sponsorship. You can see how simple it is to send sponsored calls using smart accounts. You just need to call the provider.request method with the method wallet underscore send calls and provide the parameters in the correct way to make sure that the wallet underscore send calls can use the paymaster service to send the sponsored calls or gas sponsored calls. Now that we are done with the implementation of gas sponsorship, now let's implement this on our page.tsx and demo this as well. So on page.tsx, we'll have to implement normal gasless transactions as well as batch gasless transactions as well, where we'll send multiple transactions together, and that too in the gasless way. So here I already have the code. I'll be replacing the step one code with this code, which would be our step two, add gas sponsorship and batch transactions. So here we have some new inputs. So here we have the send sponsored call import from gas sponsorship.ts and the VM imports like encode function data and number to hex so that we can send the contract calls properly. Once that is done, these are the post state. The initial few variables remain the same. In the post state variable, we add another state variable, busy and set busy. Then we have the new state for gas sponsorship and batch transactions like sponsored transaction hash and batch transaction hash. Once that is done, we have the chain ID, which would be based upon your testnet 84532 and the universal address variable as well. Then we already covered the simple sign-in handler before. Now we have the gas sponsorship handler, which would handle sponsored transactions. So here we have we make sure that the universal address is present and we set the state variables. Then we have the try-catch block where we first do a sponsored mint call using the whitelisted NFT contract. So I found this whitelisted NFT contract from the base docs itself. So you can refer to base docs as well for this testing contract. So NFT, I have set up the NFT address and the NFT ABI, as you can see, with the name type and the ABIs properly. Once it is in, we have the calls. So here in the calls, we have two value and the value, which would be 0 x 0. We don't want to send any each value over here. And the data would be encode function data with the ABI, function name, and arguments, which would be universal address. Once it is in, we have the hash variable where we await send sponsored calls with the universal address, chain ID, calls, and the URL. So here we add the next public paymaster URL as well with the type week and set sponsored transaction hash to true. Once it is done, we have the batch transaction handler where we have the handle batchment function. And here we basically do the same transaction as before, but in batches where we send 5 transactions together or something like that. So here we have the provider, get base account provider, and the NFT address and NFT ABI and the calls as well. So here in the calls, you can see a major difference where we are sending 5 transactions together and forming this as an array. And the two value and data would be same. So here, instead of transaction hash, it would be transaction hashes. And here we send the provider.request method, wallet underscore send calls, the parents like universal address, number 2 hex 84532, and atomic required because we want to send batch transactions with the calls and the capabilities like the Paymaster service. Once that is done, we have the various CSS properties that we have already discussed before. And we already discussed the header and authentication on how they would work. Then we have the gas sponsorship UI, where we set up the gas sponsorship payment button and the various transaction buttons, and also the batch transaction buttons as well. So this finishes up the UI for base accounts demo. Now let's test this out. So here on the terminal, let's just run npm run the again, and we'll load the refresh state this time with the new UI. So local C11, create wagmi yet. That sounds correct. So if you click on this, it should be authenticated like before because it saves the state in the local store of the browser as well. So first, let's send a sponsored transaction using Paymasters. So I'll just click on this button. And here, as you can see, it also shows us the asset changes like the smart wallet early adopter with the network fee is 0 because it was sponsored by our demo, which is Hamlet's demo, the Paymaster URL for Hamlet's demo. So I'll just click on confirm and it will ask for a passkey. I'll just sign the transaction. And that's it. We was able to send the sponsored transaction as well. So now that we have tested normal gas sponsorship as well, let's test batch transactions as well with gasless operations. So I'll just click on the batchment button over here. And here, as you can see, it shows us the asset changes properly. Like we are minting 5 NFTs together in a single batch transaction. And here, all of the network fees is 0. It's sponsored by Handlash Demo Paymaster URL. And like this, you can batch any kind of transactions, like 10 transactions together, or even 20 transactions, and make them gasless as well. So I'll just click on confirm. I'll just click on iCloud feature, sign the transaction. And that's it. We were able to sign the transactions for batch transactions as well. So now we can move to our next function. So now we have tackled the various common features provided by smart wallets like authentication and gas sponsorship. But what are the specific features provided by base accounts? One of them is sub accounts. Sub accounts are like child accounts connected to your main account. So basically, you can use these accounts to improve the user experience of an application where you need frequent wallet connection requests or frequent wallet interactions or transactions. So now we will implement the sub account feature by base accounts and see how they work. So here in the lib folder, we'll create another file, sub accounts sub-accounts.ts. And here we will create this sub-accounts.ts file logic one by one, and we'll tackle each function um, one by one and see how they work. So first of all, we'll start with the imports and the first function of this sub-accounts.ts file. So I already have the code. So first of all, we get the base account providers. This import is going to be in every file of the lib folder to make sure that we get the base provider instance, and this base provider instance is consistently used across the application. So we import ensure base provider connected and get base account provider. And then we have a minimal interface for sub account info as created by wallet underscore get sub accounts. Now, what is this wallet underscore get sub accounts? This is a feature provided by base accounts or smart wallets, and we can call this using provider.request method. So here we have the address, we have the factory and the factory data. Next, we have an interface which defines the get sub accounts response. So here, this would be a sub accounts parameter with the array of sub accounts info. And next, we have the type add sub account response with the sub account info response type. Next, we have all of the comprehensive functions which handle sub-account management for base account, and we will implement all of the sub-account capabilities from base account documentation. So you can always check out base account documentation to know more about this and how they improve the user experience for any application. So first of all, we have the function to get existing sub-accounts for the user. So we have the function get sub-accounts where we use a universal address. So this universal address is the main address for the user. Then we have the chain ID and the domain. So first of all, we get the provider using get base account provider and ensure base account provider is connected. Next, we have the try catch block where we get sub accounts using provider.request method. And in this, we call the method wallet underscore get sub accounts with the parameters like version, account, domain, and chain ID. So here we are using base chain ID, and we make sure that this matches the type as well for type checks. And next, we'll return the sub accounts from this function. And we have a error catching block as well to make sure that if there are any errors, it shows up in the console. Next, we have the create sub account function. So this function will create a new sub account. So this function will take three parameters: the account type, the factory, and the factory data. And this returns a promise in the form of an address string. And here, the first two lines will be same for every function, setting up the providers. Next, we have the try catch block where we'll use the const new sub accounts to call provider request with the method to wallet wallet add sub account. So this method adds a sub account for the main wallet with the params version and the account. In the account, we have sub params like the type where we define the account type and the factory data. And next, we'll make sure that this matches the sub account response type that we defined before. After that, we have the catch block, which makes sure that if there are any errors, it shows up in the console error logs. After this, we would have some other utility functions to make sure that if a sub account is already created, we don't create another sub account. So we would have the get or create sub account function. So in the get or create sub account function, we have the parameters universal address, chain ID, and domain, like the get sub accounts function. But the only difference between this and the get sub accounts function is that this will check if the sub account already exists for the domain. And if it does not exist for the domain, it will create a new one. And that's it with this function. That's the only difference between the get or create sub account function and the get account function. This is an additional check to make sure that if a sub account already exists for the domain, it doesn't create one. After this, we have some other utility functions that we won't use for this application, but we'll keep it here for the explanation purposes, like deleting a sub accounts or transferring between the main account and the sub account. So I already have the remaining functions. So we'll go through these remaining functions one by one. So first of all, we have the transfer funds between main account and sub account function. So this will transfer funds between the main account and sub account. And here we'll keep the various parameters like from address to sub account amount and chain ID. After that, we have the try catch block where we use the provider.request method. And here we'll use the wallet underscore send calls method with the params like from, chain ID, version, calls, and various subparameters to calls like to, value, and data. And then we console log. And if there are any errors, we'll make sure that the errors show up in the console. So here, transfer to sub account function works like any other wallet underscore send call function, but we are keeping this over here just in case if you want logic in your application to transfer funds between main accounts or sub accounts. We won't use this for the demo. Next, we have execute transaction from sub account. We'll be using this for another feature known as subscriptions. So here in the execute from sub account function, we use the sub account address, calls, and chain ID as parameters. And next, in the try catch block, we use a provider.request method to uh, void underscore send calls with the parameters. And then if there are errors, it will return the errors as well. So as you can see, each function is a derivation of the provider.request method, but each function has its own method. So in this function, we have wallet underscore send call method. In the next function, we have each underscore call methods. So each function calls the provider.request method, but with different methods like wallet underscore send calls or get sub accounts method. So with that, we are concluding this file with the get sub account balance function where we take the sub account address and token address. And here we have a try catch block. So if token address is there, we'll get the ERC20 token balance using balance of address. And this data basically translates to the function selector balance of. So this basically describes the balance of function. And here the provider request method calls ETH underscore call. So basically this defines to call the balance of function in the ERC20 contract to get the sub account balance. And else we'll keep another function block to get the native ETH balance for the sub account. So here we'll use provider.request method with the ETH underscore get balance method and with the parameters. And if there is any error, we'll make sure that the error is returned through console. So here in this file, we describe the various sub account functions that we can use for this demo. So here also we saw the importance of provider request method and the various methods that we use to call for transactions and various read calls. Let's test sub accounts as well. So we were on step 2 before, which was cash transmission and dash transactions on page.tsx. So now we'll add the sub accounts function, use state variables, and its return UI component as well. So I already have the code. We just go through the how the new state variables for sub account would work. So the only new input here would be the get or create sub account and get sub accounts from sub accounts file. Once that is done, we have the new state variables for sub accounts like handling multiple sub accounts and not a single sub account as well. Once that is done, we can move to the sub accounts handler functions, which would be handle create sub account function. So here we will just call the get or create sub account and refresh the sub accounts list accordingly as well using sub accounts file that we created before. So this would be a sub accounts handler function. And then if we move to the return UI component, here you can find another section which we have added for sub accounts, which is at the end of the page. So here we have the sub accounts function where we can create isolated accounts for specific use cases, reducing signing problems and improving UX. So this sub account can be used for any kind of transactions. So we are done with the UI as well. So let's run this. I'll just run there. You can go to localhost 2000. So I'll just go to localhost 2000. So they should be authenticated. So yeah. So yeah, now we have another card which is sub accounts card. So I just click on create sub account. So this time when I click on create sub account, it won't add any signing prompts or it won't show any signing prompts because I have already created a sub account before. So if I just click on create sub account, it will just directly show my sub account status. So as you can see, it's showing my sub account with the total sub accounts number 21. And this sub account can be used for any kind of app operations like isolated operations with reduced signing prompts. So as you can see, it will directly fetch the account and it won't ask for your signings in a safe executed manner. So with this, step 3 is complete. Now we can move to the next functionality. Next, and the final feature that we are going to implement for base accounts are spend permissions. Spend permissions lets you designate a trusted spender that can move assets out of the user's base account on their behalf. So it kind of works like real world subscriptions, and you can implement subscriptions on chain using spend permissions. So basically, for example, if you want to set up a subscription for a blog and you want to ask 1 USDC from the account, you can use spend permissions to set up those subscriptions. So in the lib folder, we will create another file, uh, spend permissions. API.ts. And here we'll keep the logic on how to implement spend permissions for any application. Now, before we finish off the spend permissions.ts file, we need to create some APIs to store the spend permissions and its configuration. So these configurations are, it's not secure to keep this in client-side storage, and it's always safe and secure to keep this in a server storage to make sure that you don't expose these secrets to uh, uh, evil entity. Before we complete the spend permissions.ts file logic, we need to create an API to store the spend permissions configuration. So we specifically need this API to make sure that we are not sharing the secrets in client-side storage, and instead we are properly creating server-side storage for all of the sensitive credentials and sensitive storage data. So in the API folder, we'll create another file. We'll create another folder basically, which would be subscriptions. So I'll just navigate to API and I'll create subscriptions. And here we'll create another folder, save. And in that save folder, we'll create API.ts. Let's navigate to API.ts. So here we will have all of the logic that would save subscriptions in in-memory storage. So in production, always make sure you're using a proper persistent database storage. So I already have the code over here. Let's go through this and see how it works. So first of all, the only import would be import next response from next server to implement APIs. After that, we'll have an in-memory store for this demo. Always use database in production. So here we have an array with the ID, signature, spend permission data, metadata, and the created at to make sure that we get the date when this subscription was created. After that, we have the function which saves a spend permission signature for subscriptions. So we have this post API where we first have the try catch block where we first get the JSON body from request, and if there is no body or if there is no request body, we return next API error. After that, we construct the subscription with some dummy data like ID. So here we are passing dummy data. Then we have the signature where we pass body or signature, spend permission data, which we'll get from the request, metadata we'll get from the request, and the created at field where we'll set up the date that this subscription was created. After that, we'll push this to the in-memory array storage and we'll do a console log and we'll return this in a JSON format. And after that, we have the just a minute. Yeah. After that, we have the catch block where we return Next.js next response error that if there was a processing error or there was an invalid JSON error. Once that is done, we have the get all subscriptions. Again, this is for demo purposes. It's up to you what are the various different requirements for your application. So here we will make sure that we are able to get all of the subscriptions from the in-memory storage. Again, here a persistent DB is always recommended for production. So here we'll get the search params from the URL. We'll get the user address and we'll filter the subscriptions out. And if the user address is present, we'll filter the subscriptions accordingly and we'll return the Next.js response. And next we have the execute subscription for backend use. So here we have a put API where we have a try catch block where we first get the requested somebody, and from there we get the subscription ID and amount. And we have an if check to make sure that the subscription ID and amount are present. After that, we get the subscription using subscription show.find method to get the subscription from the array. And once that is done, we just console log that executed subscription. Again, this is only for demo purposes. In production, you would validate the spend permission, execute the transaction on chain, and update the subscription usage and return the transaction hash. Because spend permissions are only used to set up the subscriptions, you still need to write the logic behind how the subscriptions would work, and if the subscription passed, what different data access would you give. So this all is set up by your backend, and you would have to write the logic for this. So make sure that in production you validate the spend permission and execute the transaction on chain using base accounts. So after that, we return the next response.json with all of the response body, and we have a catch block to catch errors as well. So in this is more described, or this is more useful when you're working in production scenarios and you have certain subscription logic that you actually want to implement. So for example, in this put request, you would have something like, for example, if you have a block subscription. So in this, you would execute the transaction, and once the transaction is done, you would give the access to the blocks to the user. So we are done with the demo API functional logic. Now we can move to spend permission.ts and finish off the spend permissions implementation as well. So I already have the code for this file over here. I'll just paste it and we'll go through this line by line and see how it works. So first of all, we get the provider from the base account providers file. And then we have some imports from the base org/account package like request spend permission and prepare spend call data. And we have kept a simplified type alias for the permission object, which is returned by the SDK. Next, we have the request spend permission function, which uses the SDK helper. And here are the various definitions for the various parameters taken by request spend permission. First, we have the account, which is the user's base account. Next, we have the spender. So I have spender address that will execute future transfers. Next, we have the token, the ERC20 token address. Allowance, so spend limit in token base units for each period. So allowance could be 1 USDC, 2 USDC, 5 USDC, whatever works for your subscription. Next, we have the period in days, the recurring period window. So for example, a monthly subscription could be 30 days, a yearly subscription could be 12 months, depending on that. Next, we have the chain ID, which is the chain on which the permissions is valid and the transactions would be executed. So here, we have first we set up the provider and then we set up the permission variable where we await the SDK request spend permission promise with the various parameters that we just described and return the response. Once that is done, we have the next function which prepares and executes the spend calls using wallet underscore send call v2s. So on first use, it returns the array which typically inputs approve with a signature and then spend. On subsequent request, only the spend call is included because the user already confirmed the subscription. So here we have the permission, the amount, and the spender with the chain ID. And we first get the provider, then we prepare the calls. And here with the transaction hash, we use provider.request with the method wallet underscore send calls with the parameters which we have already discussed before. And we return the transaction hash. And next we have an optional storage helper for the demo where we have the function storage spend permission with the permission and the metadata. And where we call the /API subscriptions /save, which we just implemented to store the subscription body and the subscription data. And here we pass the headers, the body with signature, spend permission data, and metadata, and return the response. So this is an optional storage helper for the demo. In production, you will replace this with your database and proper authentication. Now let's test out how spend permissions work. So we have already created the spend permissions for PS4. Now let's move to the page of PS6. And here we'll add the step 4 UI code, which would be spend permissions. So I already have the code over here. So we are now on the step 4 spend permissions. And here the new import would be request spend permissions and show spend permissions from the spend permissions.ts file. Once that is done, we would have a new state for the spend permissions like the spend permission created new state variable. And once that is done, we have the various other components that we implemented before itself, like batch transaction handler and sub accounts handler. Now we would have a new function to handle spend permissions, which would be the handle spend permissions handler. So here we first of all make sure that the universal address for sub account is present. If both of those are present, then only you can use the spend permissions handler function. And here, first of all, we create an allowance. So this would be around 1 USDC. So this is token based units. So that's why we have kept it to token based units. And next we have the permission function where we use request spend permission to create a permission using the universal address sub account and USDC on base mainnet. So spend permissions can only be created on base mainnet. And with the allowance and the various other parameters for base mainnet for USDC. And then we store the spend permissions on our server. And once it is done, it will alert us that the spend permission is created and stored. And then we have the catch plug which finishes up the function. So that is the handler spend permission for page.tsx, which would handle the spend permissions.ts file functions according to this UI. Next, we have the cards that we already created before. And if you go to the end, after sub accounts, we have added another spend permissions block, which would execute the spend permission transaction. So here we have various warnings to create the sub account first as well. And if the spend permission is created, it will show it in the UI as well. So now let's test it out. I'll just run npm run there. We get the local OC one. Here we can click on sign with base, and it will show us authenticated state already. So first, as you can see, it will ask us to create the sub account first. So here we won't be creating the sub account. We would be fetching our previous sub account, which is the same address as you can see. So here we will click on the create subscription button. So as you can see, it's showing us the UI as well for spend permissions with the warning as well, like transfer to 1 USDC a month until remote. And you can manage the spend permissions in this specific account settings as well. So I'll just click on allow. It will ask for my sign. Uh, I'll just sign this using my passkeys as well. And that's it. We were successfully able to create the spend permission as well. And the spend permissions has been created and stored in our Next.js server. So now with this, we are done with the major functionalities. And now we can finish off the UI with sign time data and base pay demos. So we move on to implementing the UI for this Next.js project. We will implement the one final functionality from base accounts, which is signing type data. So in the lib folder, we'll create another file and capabilities ts. And here we'll keep a function which could execute sign type data, and user could sign that on their wallet. So I already have the code over here. So this one's going to be short. And this would only have a single function which would sign the EIP-712 type data with the user's base account and returns the signature hex string or null if the user rejects. So we import the get base account provider and ensure base provider connector from the base account providers. And then we have the function sign type data with the user address, domain, types, and the message. So, and here we first get the provider and ensure that the base provider is connected. Then we have the try catch block where we have the signature, where we await provider.request with the method e underscore sign type data underscore v4 with the params user address and the other params like domain types, primary type, and message. And once it is done, we return the signature. And if there is an error, it returns null. So this is for signing custom messages that you would have for your application. So if you have application specific messages, you can use functions like this, which is the EIP-712 type data to allow users to sign custom messages as well. So now we can finish off the UI implementation with the sign type data integration as well as the base pay integration as well. So here in the page.tsx, we'll add the new integrations for sign type data and base pay integrations. So I already had the code. We'll go through this carefully and see how the complete tutorial would look like with base pay as well. So here we have some new imports, as you can see. So first of all, the new import would be sign type data import from advanced capabilities and the base org account imports like pay and get payment status from base org slash account. So this would allow us to set up base pay in our UI. Once that is done, we have a new use state variables for type data signing state. So here we have the type data signature use state variable and the new states for base pay as well. So there would be two new state variables for base pay, which would be payment status and transaction hash. So once that is done, we can move to the next functions, which would be the type data signing handler. So here we have the handle type data function, which would basically first make sure that the universal address is set up. And then we have the try catch block where we construct the message. So we have this domain variable where we have the name, version, chain ID, and verifying contract. Uh, Now, with this verifying contract would be an actual verifying contract for now. Demo purposes, we have kept this address. Then we have the types of this message as well. So the first in this message array, we have the first name, content string, and then we have the timestamp object as well. And then we finish up the message with the content and the timestamp. After that, we ask for the signature using sign type data function. And with that, we are done with the type data signing handler function as well. And then we have the base pay handler function, which would handle the payments for using base pay. So here we first set the payment status and transaction add to pending and null values. And then we have the try block where we first have the we initialize the payment using the pay functionality import from base org/accounts, and we keep the amount to 1 USDC to two address, and we keep the testnet to true. So if you want this to work on mainnet, you would have to keep the testnet to false, and then we check the status of this base pay functionality or transaction. So here in this try catch block, we get the payment status using the get payment status from um, base/accounts SDK. And here we pass the parameters like ID and the tested parameters. And if the status is completed, it will show the status completed. Else if it will show just the payment status has failed. And then we call this status function as well. After that, we finish off this function with the cache block where if there are any errors, it will directly show us error as well. So now we are done with the variables and the functionalities for base pay and sign type data as well. We'll just add this to the return component of our UI. So if we move down after spend permissions, you can find the type data signing UI as well, which has various buttons to handle the transaction. And then we have the base pay UI block as well. So here we'll use the functionalities or functions that we created before to create a seamless USDC payment with built-in on-ramps like Apple Pay and debit card, which is provided by base accounts itself. So here, with this, we will complete our demo as well. So we have kept a final completion message as well. So now let's test this out. So I'll just run npm run there. Once that is done, we can move to our browser, click localhost 3000. And you can connect our wallet again. So we click confirm. It will ask for sign with base. We'll sign in as well. Confirm. Passkey. Once that is done, it will show us the authenticated state. And here you can see two new cards, which should be type data signing and base pay demo. So I'll just first sign the demo message. So here you can see the message that we just constructed before in our function with the base accounts demo message. So I'll just click sign. I'll just my passkey. So as you can see, the type data signed was successfully with the signature as well. Now, next, let's do the base pay demo and see how the UI for base pay demo would look like. So I'll just click on pay with base pay. So as you can see, it is showing us the UI for base pay 1 USDC to this address, which we have already set up in our previous function. But I currently don't have testnet USDC, so I can't approve this transaction. But this is how the base pay UI would look like if even if you're using it on testnet or mainnet as well. You can set any amounts that you want. You can pay. You can keep the amount to 100 USDC, or you can keep the receiving address to a different address as well. But the main motive of base pay is to provide you as much customization as possible with payments. So I'll just click on cancel here, and definitely it will show payment fail. And with this, we have completed the base account tutorial demo also. And there you have it. We have written on-chain app with a secure, seamless passkey-based login, one-tap USDC payments, and implemented a fully automated gasless subscription model. You now have the foundation to build virtually any DApp with a user experience that's ready for millions. For more information, the best resource is the CDP and base Discord server. The team and the community there are incredibly active. Also, you can always refer to the official base accounts documentation for more detailed references. Also, make sure to check out docs.cdp.coinbase.com and docs.base.org for more information on other tools and services provided by the official CDP and base team. Also, for more tutorials like this, make sure to check out handless.com. From here, you can explore more advanced CDP and base features like integrating other on-chain components for swaps and NFTs, or connecting wallet providers and services like CDP embedded wallets or CDP embedded wallets to create even more advanced and powerful onboarding flows. If this guide from Handless was valuable, please hit that like button, follow for more advanced on-chain tutorials, and let us know what you're building in the comments below. Thanks for building with me today. See you in the next one.